Welcome back. In this video, we're starting section 1.2. We're going to define the inverse trig functions. All right, so this is the real start of Cal. What we did before was mostly a review or highlighting some things about what you've done before. All right, so our goal for this section is to define the inverse trigonometric functions arcsine, arctangent, and arccosine. We need to graph them and we need to evaluate them at nice values. There will be some limits, some derivatives, and stuff like that in future chapters. All right, so let's start with arcsine. Definition of arcsine. Let's look at example 1.1. I want to graph y equals sine of x and determine whether this function has an inverse. All right, so sine starts at 0, 0. And then it's 0 again at pi and at 2 pi. And then same thing on the other side. It is positive at first, then negative, then positive. The max value is at 1, min value at -1. And keep going like this and like this. All right, let me highlight a few points. This point is at minus pi on 2, so it's minus pi on 2 minus 1. This is 3 pi on 2 minus 1. This is pi on 2, 1. All right, so we want to know if this function has an inverse function. Let's put function just to really make a point here. So if I flip this, I'm going to get 0, 0 still. I'm going to get pi on 2, 1. I'm going to get 0 pi, and then I'm going to go on the other side. I'm going to have 3 pi, -1, 3 pi on 2. And so if I actually sketch this, it's going to look like this, like this, like this, and the same thing on the other side. Sorry, this is a bit off. So the sine wave is now going vertically. All right, so the question is this potential inverse a function? Well, it isn't, because if I look at different values, so let's pick, even for something like 1, we have a problem. So this function fails the vertical line test. Or even at this point, you could see I would fail the horizontal line test. All right, and so that means that this function is not invertible. All right, but we've seen this with x squared. It's not because there's no inverse that we can't actually work with some sort of inverse-ish. So the next question will have us think about that. On which interval could we restrict y equals sine of x to ensure that it passes the horizontal line test? All right, so let me resketch. I think it's going to be easier to follow if I have a new graph. So I'm going to sketch it like this. So let's say I want to include 0, just because we like 0 so much. I want to include 0, and I want to include as much as possible of this graph without repeating any value, but without hitting the same horizontal line twice. So I would be able to go up to here, but as soon as I go a bit further, as soon as I reached, sorry, didn't mean to erase the curve. As soon as I reach the top, I have to stop. So I have to stop at this top. And if you remember, this top was pi on 2, 1. If I keep going, I will be repeating value. I will be hitting the same horizontal line again and again. And same thing here. Here I'd have minus pi on 2 minus 1. I can go all the way here, and if I only look at that orange bit, any horizontal line would hit this graph only once. And so I would restrict to minus pi on 2, pi on 2. Then it would pass the horizontal line test and you would have an inverse.